Welcome to the presentation about the overview of our VDMA's OPC UA activities. As mentioned, my name is Andreas Fahrt, and I'm leading the department Machine Information Interoperability. And this is exactly what it is about today. The machines, their information, and how to provide this information in an interoperable way. I will shortly go into the VDMA. Then I will explain why interoperability is so important for digital transformation at all. And then I will go a little bit into the OPC UA Companion Specification work we do inside the VDMA with a lot of member companies, but also companies and users worldwide. And after this, I shortly dive into the UMATI initiative for just an insight, because this will be shared in one of the next upcoming sessions anyway. So the VDMA, and I guess most of you know that, is the most important industrial association in Europe. We are covering about today 3,600 member companies from the engineering industry, and we are structured in different trade associations covering the specific needs of the different areas, like, for example, plastic and rubber machinery, robotics, measurement systems, power systems, agricultural machines, and so on. And in addition, we got 6 German regional subsidiaries, but also global subsidiaries, where we have our traditional ones like in Brazil, China, India, Japan, and Austria. But we are also getting new subsidiaries all over the world, like in the States, for example. So the most important thing is that everything I tell you in this presentation is covering information and activities regarding the whole machinery industry, as the VDMA acts as an umbrella association for the different domains. And with this, we also have the position of the mechanical engineering, as this is what we believe in the center of the whole production life cycle. Also for end customer products, machines from the mechanical engineering industry are critical important, as they are the assets in the production used to produce almost everything we know from our professional and daily life. So with this, we have really the heart chamber of innovation, and also the term, for example, Industry 4.0. And if we go to the point of Industry 4.0, most of you should know the platform Industry 4.0 by government driven, and they have a vision for 2030. And what we see here is the point of autonomy, sustainability, and interoperability. So for the area of interoperability, it is, of course, about information data, but also about regulatory frameworks, and, for example, stuff like artificial intelligence, because everything is based on information that has to be provided in an interoperable way to scale and to use the full potential of the different technologies and concepts. So what is our goal? And I guess this is what you all are doing some way. We are looking for a smart production of the future. So the topic of digital market platforms, customer specific, but still mass production, the integration of machines, products, and systems in the internet technologies with plug and work and stuff like this is all on our minds. And a lot of this is already achieved. Where we are still looking to is what role is information having in our daily work. And we believe, and also a lot of others, of course, do, that today and also in future, data and information are the most important resource. What does that mean? This is more than just data availability, because data availability of our own data today is not the problem. Also, the storage of this information is in an efficient way is something mostly is solved. But the way to use external information to have an efficient data transfer and data transparency, to be able to compare data and information without having a not efficient interpretation of all the information. This is really something we have to work on, and this is where often mistakes and problems occur, because, for example, we also have really not an error-proof data interpretation in our daily work. So the processing of the information and the scalability of our algorithms, applications, concepts, and so on is not taking the full potential, because we still have not these really information-driven business models and the efficient realization of the information-related regulations coming up, because data is hard to use when it is not standardized, when it is not available in the same way along the whole value chain, and is still proprietary defined. So for interoperability, there are three major goals, and they all belong to the last two slides where I explained where we have problems, what is the final goal for intelligent production. Because we want to have the reduction of non-value adding work. Non-value adding work, for example, is redefining interfaces again and again without changing the content. So we want to simplify interfaces development by standards. Second thing is we want to have an efficient integration of new machines into green and brown fields. This only works if the interfaces are known and easy to use, and hopefully not changing by the change of the machines or the manufacturers. So the simplified integration by using of standardized interfaces is the next big step to really reduce the costs and time and duration and off time of running productions. And last but maybe most important point, and this is where the machine builder is changing its view from a company providing or selling machines to a customer to being a customer by producing its machines in its production. So the simplified access to standardized production, to easy compare it, to easy use it, to get a more efficient production and better usage of the information. So we believe the competitiveness is increasing and costs are reduced by the use of standardized interfaces for shop floor information. What is needed is a global production language. And this global production language is based on a standardized vocabulary. So in the opposite way, like we have in the Babylonian clamor, where nobody was able to understand each other, we want to have a standardized vocabulary. And this standardized vocabulary really has to be hardly straight and clear, because a machine is not able to understand that hello and hi may be the same meaning. It really has to be 100% exactly the same. So this is why we have to define technical standards. And those technical standards, or kind of them, you all know. Because if you're connecting your laptop to a printing device or your mobile phone to your car, you know all about the Bluetooth standard. So with this Bluetooth standard, you are able to get a connection between two devices that never were connected before, and you don't have to read anything like handbooks or something where it is explained what is meant by the different interface information. So you just connect to Bluetooth and you just connect to the next asset that you want to, that is also having Bluetooth. Why is then also the function working? This is because inside the Bluetooth community, there exactly were groups defining the standardized information that is exchanged for the different function, jobs, and information transfer between the different use cases, for example, audio, telephony, and automotive. So This is the same thing we have in future and also today in some parts in the industry. But of course, we are not using Bluetooth, we are using something else. And this something else is OPC UA. So the OPC UA standard, it's an IEC standard 62541, is an open source architecture. It has security by design included. It supports various protocols. It has a semantic machine description available, and it's scalable. It scales from just 1 node to 1 million nodes from the shop floor up to the cloud in a vertical and also horizontal network. So with OPC UA as our industry-driven comparable Bluetooth connection possibility, we have from the manufacturing industry the possibility to really reduce development of interfaces, have easier integration, and better, clearer usage of information. So OPC UA stands for Open Platform Communications Unified Architecture. And at first, and I mentioned that, it's protocol independent. So it's not bounded to, for example, MQTT or HTTPS. Of course, MQTT, for example, is part of OPC UA. So you can use OPC UA with MQTT inside. So the question, do we use OPC UA and MQTT, is not the question. The question is, do I want to have the benefits from OPC UA, like security by design and the possibility of the companion specifications, so the domain-specific information models, or I want just to have MQTT possibilities and features. So as OPC UA is fulfilling all the requirements we have from the machinery industry, it is the favorite open source technology for communication of shop floor information. And for us as the VDMA, as an association, as a platform for domain experts and companies from the machinery industry and also their customers, there is the most important thing, and that's it, companion specifications. So companion specifications are the tool how to not just have the communication like with Bluetooth, but also have the specification where it is defined which information should be transferred, how it is described, what is the meaning, which data types are supported, and for example, also which measurement unit is this specific variable. And this is defined in the companion specifications and developed by domain experts, because industry know-how is so important in that point, and it has to be developed bottom up. So with this, I want to go 1 point deeper to the OPC UA technology. The OPC UA technology has exactly the 2 areas: transport, so just Bluetooth, just connection, just OPC UA, including protocols, including rules and right management, including security and stuff like this. And then we have the information layer, exactly where the standardized information, the content is defined and can be standardized. And for the transport area, we have the possibility on client-server communication. We have the possibility of publish and subscribe communication. And of course, we have the underlying protocols. For the information layer, we have 2 basis areas that is developed by the OPC Foundation. OPC Foundation is the global association covering the development of the OPC UA technology. And then we have these OPC UA companion specifications developed, hosted by the VDMA and its partners. And if we would stop there, there were no chance that companies could put in their not just pre-competitive relevant information into the technology, into the interface, because they want to do and to have their specific information that is not shared in our working groups to the standards, to the interfaces. We have the vendor-specific extensions in OPC UA. So in the vendor-specific extension, every company, after they implemented the OPC UA connection and the OPC UA companion specification, can add really specific their individual information to the interface. So the question if machines get easy replaceable or pushed out of the market by competitors is not the case, because still vendor-specific information and interfaces and value can be put into the OPC UA interface still if there is also an OPC UA Companion Specification that serves as the basis of the interface, of course. To understand what OPC UA Companion Specifications really can do and why they are so good and easy to use for the industry, I would love to explain the two kinds of OPC UA Companion Specifications we have in the mechanical engineering industry. At first, we have the domain-specific harmonized information models. Domain-specific harmonized information models means that for the different domains, the domain-specific information is taken from the domain experts and they are standardized in these specs. So information like, for example, identification or a job management that is not specific on the domain will not be covered here because it's cross-domain relevant. Stuff like in the robot area, an axis rotational speed, or at the weighing technology, some scale values is domain specific, so it is covered here. So this gives us the chance to go on the highest level of interoperability by our cross-domain harmonized information models that we call OPC UA for machinery. So in this OPC UA for machinery, we're also in one of the next sessions will be a deep dive. We have the possibility to do exactly the cross-domain relevant information. And this is something like machine or component identification, like states of machines, like process values, result transfer information, counters, or something like job management that was recently released. And upcoming and in work, for example, the topic of basic service structure and energy management. So if we go from bottom to the top, we have the different levels of interoperability. In the old world, we had the proprietary communication with no standardized information and no standardized connection like communication. Second, we have the standardized meshed communication network by the OPC UA technology. Next level, we have domain-specific information standardized. And on the last level, we have, in addition, the cross-domain information standardized. So really, a bunch of information is already standardized by the groups and can be used in the industry because it's also open source and free available and also used in several products now. So the OPC UA for machinery, to go there just a little bit in, is for the whole mechanical engineering industry. And it is based on building blocks. So if a machine has an identification, you can implement the identification building block. Well, all machines have an identification, because this is kind of a basic building block everybody should use. But for example, a state machine, maybe not everybody has. So if you don't have it, you could leave it out. And so it's highly flexible and it can be referenced from all the other companion specifications or also be implemented as standalone model. So the OPC for machinery is the basis spec for the whole industry. And if we look on how this is then used, normally there is first the implementation of the OPC UA for machinery, and after it there can be the use of a domain-specific information model. If there is just one, it perfectly fits. If there is, like at the machine tool area, one specification that is for the machine tools, and this has also a second specification that is having more specialized information, for example, lather machines, there could also be 3 specifications used together. But as mentioned, also OPC UA for machinery as a standalone model can be used for machines where we just have no specification today, or that is really a specific machine where there is not a group of competitors can come together and define a standard. The companion specifications we already developed and released is on the left side. So you see, this is really a lot of specifications, and you can also see the OPC UA for machinery basic building blocks, process values, job management, result transfer. And also you can see it's really widely spread over the whole industry. We start from robotics, go over cranes and hoists to plastic and rubber machine, up to mining industry and process air extraction and filtration systems. So we have more than 60 actual published specifications. There are much more, but of course we did some versioning. So we have 60 to use specifications, more than this actually released, and they are open source available. And this is still not the end. There are coming even more specifications, like for battery production or wire harness manufacturing, to just name a few. So the mosaic of a standardized production is getting clearer and fuller each day, each month, with each group that doing a release. The question often that occurs is, why do you do standardization on the shop floor side, on the machine side, with the domains? And the clear answer is, if there would be use cases defining their own information, we wouldn't lose the game if we look at it on a holistic level. Because then the machine manufacturer has to develop interfaces for the different use cases, and we wouldn't win anything with the approach. So it's extremely important to have the information standardized at the single source of truth. And the single source of truth for information that is coming up in the production is at the machine side, latest at the PLC. So defining the information directly for the machines and then use this standardized information and semantics in all different kinds of use cases is extremely important, because then the use cases can use the same source, and also the use cases are interoperable regarding their semantics of the information from the production between each other. So how does the typical development of such an OPC UA companion specification look like? Well, we go from a preliminary work where we have to see if there is a demand in the industry and see how we can involve different parties, up to the content work where we talk about which machines and which kind of information should be in the standards. Then we put it into the OPC UA technology, serving us kind of a grammar. And then we do the publication and, of course, a proof of concept. During the content work and the OPC UA designing, of course, there is a consistency check by the OPC UA for machinery usage, and also between checking between different specifications by checking if there is double work or work already done that we can use. And this is really done on an international, global level. We are not only showing the information in global events with our partners and also trade fairs, but we also have international partners like users and also integrators, software companies, cloud providers, and machine builders in our groups. So if we go for the preliminary work, we have at the first point, as an example from the plasma surface technology, the first point, we have to do a kickoff. So in this kickoff, we are checking the requirements that we want to fulfill, that the industry has, and see if we can get some companies together to talk about if they want to go further, or if there maybe also is no importance on doing standardized interfaces in the domain. Normally, there is a high interest, so the groups are kicking off and starting there. The groups are mostly hosted by VDMA and in joint working groups with OPC Foundation. So we make sure that also the OPC UA experts from OPC Foundation can take part in the group, and also that our standards are having a large reach and the possibility to integrate a lot of companies that maybe are also not able to be a VDMA member, but still are relevant for the interface at all. Second step, we are defining the scope. So the domain of plasma surface technology, as an example, of course, had a lot of different machines and components. So which machines should be the most important part? Where should we start? Because we cannot standardize every machine at the same time, of course. So at first we start, what machines should be mapped into OPC UA? What machines should be in which depth take part of our OPC UA activities? And then we always start by use cases. So we never just say, let's do 50 parameters that have no value. We start always by use cases. So use cases are defined, and then we have the different parameter lists. And in the parameter list, then we have often to do the decisions, which information are relevant for the defined use cases, which information is domain specific, and which information is just so valuable that it is also for other domains important. And this is what we put into the OPC UA for machinery. And so we can define for the different kind of machines with different modeling approach, the perfect OPC UA companion specification by thinking about the later results also in the beginning of the content work, where we basically see which information is relevant for which machine and which use case. The design in OPC UA, this is where the experts really come into the play, and the domain experts step a little bit back because they already put their major knowledge into the group. And this is where we put their knowledge into the OPC UA technology, let's say the grammar. Technology-wise, it is the information modeling. So you see here an example, and I will, by purpose, not go in there, and it's still under development. But this is an example how, for example, this information model can look like. Most important, it is not a flat list. So we have the possibility to do classifications, to see dependencies, and also to have like references or add-ins that can be used but don't have to. So it's also highly modular, and it gets more restricted by using the option to have mandatory elements and optional elements. For the depth of the different areas and their information models, exactly all the other upcoming sessions are the perfect place to get informed about maybe not only your domain, but maybe also other domains that might be familiar to yours, but also maybe are totally different, to have a different viewpoint on this topic regarding OPC UA companion specifications and interface standardization. And after this, after the groups have defined the domain content and also the OPC UA companion specification, we are doing the publication. So at OPC Foundation side, there is the companion spec available. At VDMA side, the companion spec is available. It is free of charge. It is open source. Everybody can use it. And it's always a machine-readable XML file, but also a human-readable PDF to understand what exactly is done in the interface, how it should be implemented, and what is meant by the different OPC UA defined variables and structures. And we are also going one step further. So it's not only having the standard on the market, everybody can use it. We really want to have the possibility to check if our specifications are easy to implement and to fulfill the use cases we found in the beginning in the content work. There, the VDMA is stepping back because we as an association are taking care of all the different kinds of machine builders, bring them together, talk about standardization. But the usage in the industry, this is normally done by the machine builders and customers by themselves. In this case, we have sometimes a lack of experience with OPC UA or knowledge, expert knowledge, and we have to do verification of the correct implementation. And this is done by an initiative we founded called UMATI, the Universal Machine Technology Interface. And this UMATI initiative exactly steps in where the VDMA steps a little bit back by having a community that is together implementing OPC UA Companion Specifications of the machinery industry. So all the domain-specific stuff, but also the OPC UA for machinery. And the most important thing is that UMATI is open for every company. So there is no requirement on any membership. And we really want the industry to have the possibility to get an exchange between machine builders and also users and also software companies and everybody who is somehow tackling the standards from the production. So this community is talking about, for example, lessons learned, best practices, but maybe most important is that they agree on an identical implementation and are raising the international acceptance. So everybody around the world, every company can join this initiative and support the usage and do first steps in the implementation of the OPC UA Companion Specifications, and also have the possibility to get feedback into the groups for their standardization work. And this is taken by a lot of companies actually, and we are still growing heavily. And two-way, we already have more than 350 partners worldwide, which is really a success because adoption is also growing and has reached the point of no return regarding OPC UA technology anyway, but also regarding OPC UA Companion Specifications. Maybe to show you one of the different use cases that were occurring in the last weeks and months. And this is more driven by regulatories. So I think you have heard about the European Data Act. The European Data Act is really a fundamental legal reorganization of data access and data usage that is coming from the European Union. And this is really tackling all sectors everywhere in the whole European Union. And it should somehow support everybody, so also people and companies and individuals, to have more a balanced relationship between the data access and their invest. So if you are a user of information, you have the right to get the information from the machine you are using. As a private person, maybe the information from your car that the car manufacturer can get from your automotive, but as a producer with a machine on the shop floor, also the information that is given from the machine to somewhere. So there should be a higher data economy and a single market for data with more data available. And this should get an additional 270 billion GDP from the EU member states by 2028. So a huge impact is foreseen there. And if we want to do that, and if we want to have a data economy as a primary goal, with cross-industry regulation and also rules for access and fair, that should be fair and practical and clear, and to be complied by all the different other European regulations, we have to have standardized information. Because if we just have proprietary information, this wouldn't still be fair usage of information because you cannot use them. So basically, the OPC UA Companion Specifications are one good step in fulfilling the European Data Act, because they already give you the basis subset of information from the interface, readable by the customer, by the user, and also the set of information is already defined in the standard. As this is so important, we have just released 2024 in April, a quick guide regarding interoperable interfaces, standards for successful dealing with the European Data Act, where you can learn why and how exactly standardized shop floor information by OPC UA is supporting the fulfillment of the European Data Act, and also understand what really is the EU Data Act in a little bit more detail. So who has to deal with it, what exactly is on this EU Data Act, which data is meant by, and how are the different roles. For starting to get into the topic, we have our Industry 4.0 communication guideline based on OPC UA. As second step, we have the Industry 4.0 interoperability through OPC UA with companion specification. This is tackling more the benefits for stakeholders. And then we have a study done in the machinery industry that is showing why and how OPC UA is so important by some numbers and figures. And we have one short paper that is tackling capabilities and skills in production automation, also based on OPC UA Companion Specifications. So feel free to get this information, and also, of course, to visit the UMATI homepage, where you get even more use cases and information. But this, as I mentioned, is one of the next weeks with a deep dive.